Good afternoon, everyone. We're here today to present to you the St Giles Circus project based in central London. The project recently won the UK Project of the Year with a value over £3 million at the Ground Engineering Awards. My name is James Wildgoose. I work for Skanska, who are the main contractor for the works. I'm Skanska's senior engineer on the project.
Hello, my name is Clive Fussell. I'm a director at Ingenuity, and we've been involved with the project from planning through to structural completion.
St Giles Circus is located in the heart of the West End, just next to Tottenham Court Road station, and actually above part of the station. And to the west, well, to the west of it is Charing Cross Road. There are 4 buildings above ground, shown in blue, creatively named buildings A, B, C, and D, which are a mixture of steel and concrete frame buildings. To the south of the site are a number of existing buildings, shown in red. They a mixture of listed and unlisted buildings that are refurbished, and a number of structural alterations undertaken to them during the works. The basement is shown in yellow. The boundary of the basement is in yellow. There's a 4-storey basement that sits below the new build buildings, and also some parts of the existing buildings that are retained. The project itself has a bit of everything. The buildings range in heights from 4 stories to 7 stories. There is a retained facade to one side of the site, right there, Denmark Street to the south, and also within the basement itself is a 2,000 person flexible space auditorium.
To the west of the site, shown in black here, is the line of the Northern Line, which runs under Charing Cross Road. And just above the Northern Line, shown in purple here, are the ticket halls and lower concourse for the Tottenham Court Road station. Linking the two, underneath the west side of the site, under the Charing Cross Road frontage, is the Northern Line escalator box, which runs underneath the proposed basement. And also running underneath the proposed basement from west to east, shown in green, is the Crossrail tunnel, the eastbound Crossrail trains. Westbound tunnel being slightly further to the south side. Next slide, please. To the south of the site is Denmark Street, which, as James said, is involved with the site, and a number of the buildings on Denmark Street were refurbished as part of the development. Denmark Street, though, contains about 6 or 7 listed buildings, a number of which, the rear of which fronts back onto the basement. These buildings were obviously very sensitive for any movement associated with the basement construction. Next slide, please. On the north side of the site, obviously we have the Tottenham Court Road station with the ticket hall box only a couple of metres away from the proposed basement, and also centre point slightly further to the north. These provided some significant constraints on the logistics for the basement construction, and also on this side of the site were some high voltage cables, which again influenced the location of the piles on the perimeter of the site. Next slide, please. The proposed scheme incorporates, as James said, a 7-storey building, but 4 stories of this 7-storey building form an external urban gallery or event space. So the majority of the building superstructure does not sit above the proposed basement or above the Crossrail tunnel. As a result, the basement construction will remove a lot of overburden from above the tunnel, and this won't be replaced by superstructure loads. Therefore, a significant amount of heave and potential movement would occur to the tunnel unless other interventions were made. Directly above the tunnel is a 2,000 person capacity auditorium, and the client had a desire to make the floor to ceiling heights in the auditorium as large as possible, aiming for in the order of 9 to 10 metres, which again not only increased the size of the basement footprint, but also increased the depth of the basement above the Crossrail tunnel. So the construction of the basement is just 6 metres above the crown of the Crossrail tunnel, the minimum allowed for within the Crossrail guidance. Next slide, please. So the initial basement scheme for the St Giles Circus development involved constructing a top-down basement, effectively in 3 parts, with one part either side of the Crossrail tunnel, and the area above the Crossrail tunnel constructed later. So if we look at the slide on the top right there, we can see that we construct top-down basement construction either side of the Crossrail tunnel, and then we construct headings to tunnel under the overburden above the Crossrail tunnel to maintain that overburden and limit movement during basement construction. Once the headings were complete, these would then be infilled with an in-situ concrete beam, which would effectively form a staple with tension piles to hold the Crossrail tunnel down. Once this staple had been completed, the overburden could then be removed whilst minimising movement of the Crossrail tunnel. The movements associated with this construction method were analysed by our geotechnical engineers, Cowie, and demonstrated that the movement of the Crossrail tunnel would be less than 10 millimetres, which was within the limits advised to us by Crossrail's infrastructure production. This scheme was developed through to planning stage, and outline approval was obtained from Crossrail for the construction of this scheme. Next slide, please. Prior to undertaking a Cat3 check for the basement construction of the interface with Crossrail and the other Transport for London assets, a peer review was undertaken of the scheme by Arup Associates. Arup Associates had recently completed a similar scheme, or a scheme that had some similarities at Paddington Station for the Crossrail box, where similar geotechnical ground conditions were encountered, with London clay being the main medium for which the tunnels are passing through. And excavation was done between secant piled walls to reveal the crown of the tunnels during the Paddington box construction. Whilst this excavation was progressing, monitoring was in progress, which showed that the Crossrail tunnels moved less than originally predicted, and also within acceptable limits for Crossrail in terms of the movement of the track and the relationship between the track and the overhead line, which is a key constraint on Crossrail. As a result of that, lessons learned from Paddington were applied to the St Giles basement scheme. Next slide, please. So we revised the basement construction scheme to maintain a similar top-down construction method to before, but using the top-down method as one dig rather than the 3 previous digs. This enabled a safer form of construction to be used for basement construction and resulted in both cost and programme savings. So if we look at the slide on the left, we initially construct the piles and then cast the ground floor slab before excavating down to approximately half the depth of the basement, where intermediate slab was cast at mezzanine level to prop the retaining walls. And then excavation proceeded down to the main basement level B1, where the adit slab was cast above the Crossrail tunnel to form the horizontal element of the staple that would hold the Crossrail tunnel down to resist heave. And then once the basement slab was constructed at B1 level, basement excavation continued down to B2, where additional spaces were created for plant rooms associated with the development. And finally, box-in-box construction was built or erected on its acoustic bearings above the B1 slab for the auditorium. Again, analysis was done by our geotechnical engineers, Cowies, this time using 3D Plaxis software, which modeled each stage and showed that with this revised construction technique, the tunnel movements were slightly larger than before. We're predicting up to 20 mil movement at the crown, but only 10 mil movement at the invert where the track level was, and the relative movement between the crown and the invert therefore of 10 millimeters egging or increased height of the tunnel, which was acceptable to Crossrail. Next slide, please.
So the project began on site in July 2017 with the piling works, which lasted around 6 months. Piling was undertaken by Skanska Cementation, where there were around 350 piles installed to form the perimeter secant wall, as well as the bearing piles and tension piles in the middle of the basement space. The piling was undertaken by 2 rigs around the perimeter of the site, with the deepest piles going 50 metres in depth each side of the Crossrail tunnel, as well as some shorter piles above the existing Northern Line concourse. Within the piles was a number of monitoring equipment, including a number of bits of monitoring equipment, including strain gauges and inclinometers that were used to validate the movements on the nearby TfL and also existing building structures. The basement, as Clive said, was constructed in a top-down construction method, which had its benefits in maximising the space for the client within the basement. One of the challenges in undertaking in building such a large basement in a tight footprint was the working room around the site, of which there was very little. On the top left-hand side, you'll see a picture of some steel beams spanning across the basement structure. These were part of the temporary works and permanent works scheme to reinforce the ground floor slab, which was designed to accommodate 2 telescopic grabs to excavate the basement and also to support a series of mobile crane loads that required to erect the superstructure. On the bottom left and right-hand side, you'll see examples of more of the temporary works that were installed to form the basement structure. At level -2, there was one level of horizontal propping that was used to prop the secant wall. This was used in a combination with the level -2 slab, the permanent slab, to effectively form a ring beam around the perimeter of the site. There was also around 60 plunge columns installed to provide vertical support for the superstructure above, and also the ground floor slab and the loads required for muck-away lorries and the telescopic grabs. A combination of these temporary works, as well as others, allowed both the superstructure to be erected and the basement to be constructed at the same time. The project had an excellent health and safety record and also was a real success due to the detailed construction sequence planning and 4D planning undertaken at an early stage. On the left-hand side, you'll see a slide showing some of the works undertaken above ground and below ground at the same time. Temporary works were built into the 3D model to show where they were required, such as tower crane support grillages, and also the forest of temporary works that was required to the plunge columns below ground. On the right-hand side shows a picture later on in the project, while the final stages of the basement structure was being completed. You've got building A on the left and building B on the right, and the 3 by 7 metre mole hole in the centre of the site that was used to feed the basement construction. All of this had to be carefully planned and coordinated with our own internal trade contractors, as well as third parties such as London Underground and Crossrail. The 4D planning software was used to provide regular updates to the third parties on works completed and also upcoming works that may affect their assets. This was used in conjunction with the monitoring data to provide them assurance that the project was going as planned.
One of the existing buildings on the site had a major influence on the construction methodology and sequence of works. There's a 18th century or 1700s single-story smithy or former blacksmiths within the site, which is located in the diagram on the left in the pink area. As you can see, this overlies part of both the Crossrail tunnel and the proposed line of the heave retention piles that were required to restrain the heave Crossrail tunnel would otherwise experience. Various options were considered how we could construct these tension piles under the footprint of a smithy. Caisson construction within the footprint of the smithy, limited access piling rigs such as Martel pile rigs, or even longer super adit beams that would transfer the loads to piles either side of the smithy. In the end, following extensive negotiations with both Crossrail and Camden, solution with the lowest risk to both the smithy building, which has heritage value, and the Crossrail tunnel was considered to actually be move the smithy away from Crossrail tunnel during the piling operation and then position it back. This involved a series of strategies, including underpinning and casting a raft slab underneath the smithy, using a crane to relocate the smithy away from the line of piling, which enabled the piles to be installed. And then next slide, please. Installing a temporary support grillage, you can see the steel beams in one of the earlier pictures, to land the smithy back in its original position, at which point the ground floor slab could be constructed around the smithy, incorporating the raft slab, and then a top-down construction was able to proceed. And finally, after basement construction, the smithy could be relinked back to buildings on the frontage of Denmark Street through a new glass box. Next slide, please.
Here's a short video of the final smithy move taking place in late 2017. The smithy itself weighed around 150 tons and was lifted back into place using a 750-ton mobile crane and placed back upon the temporary works grillage. The smithy was surveyed prior to its initial move and then placed back in position, back within 10 millimeters of its original position. Piling works were paused for around a week to undertake this operation and then restarted to complete the final piles where underneath the temporary smithy location.
As mentioned earlier, the main space that makes use of the basement is a 10-meter high, 2,000 person capacity auditorium or flexible space. This space is planned to be used for a whole range of activities, ranging from product launches through to dining events, club nights, rehearsal spaces, concerts, all sorts of flexible assembly functions, basically. As a result of this, its acoustic performance is very sensitive, and with the construction being only 6 meters above the Crossrail tunnel and adjacent to the Northern Line, there was a requirement to acoustically isolate the auditorium to form a box-in-box construction. This was achieved by forming a steel frame for the auditorium, which was then supported on acoustic isolation bearings with concrete slabs and blockwork walls of minimum density, minimum acoustic mass to provide acoustic separation between the auditorium space and the surrounding infrastructure. Next slide, please.
Here's a short time-lapse video of the box-in-box construction being undertaken. As Clive mentioned, it sits on around 250 acoustic bearings, and as it had to be acoustically isolated from the rest of the basement structure, had to be constructed after the basement was complete. First, the base slab of the box-in-box was constructed and sat on 250 bearings. Next, the roof slab had to be constructed, with the longest steel beams being 19 meters long that had to be fed through the 7-meter long mole hole in the ground floor slab. Finally, the box-in-box roof was put into position and lifted in using 14 strand jacks and concreted around halfway up. The total weight of the roof was around 350 tons, where it was hung from the ground floor slab. Again, this was another one of the temporary loads which the ground floor slab had to be designed to accommodate. Finally, once the roof slab was in position, the perimeter columns were installed, the mezzanine slab was installed, and then the roof dejacked from its hanging position off the ground floor slab to rest in its final place. The blockwork walls were then constructed, and finally the mezzanine slab. Here's a small photo of the box-in-box now, which is our COVID-19 welfare area as the project comes to a completion.
During the whole construction of the project, continuous monitoring took place of both the underground infrastructure around the project and also the sensitive buildings immediately adjacent to the site. This involved the installation of 320 prisms that were movement monitored and approximately 50 tilt meters, mainly in the tunnel below the site. The graph at the top indicates the timeline during the construction phase of the project and the movements associated with those tilt meters. We can see that there are a number of triggers on the trigger levels on the graph shown in amber, red and black that were agreed with Crossrail as part of the monitoring action plan. And the blue line shows how the tilt meters movements reflected those triggers. As can be seen, throughout the whole project, the movement stayed well within the trigger levels, and this was true of all the monitoring within the Transport for London infrastructure, where no amber triggers were received. You can see at each stage of the construction, we can track the movements. So pile installation with the piles going just 2 meters away from the tunnel, caused the tunnel to belly a little bit, which hence give it a negative tilt on the tilt meters. And then as we started to excavate and remove overburden from above the tunnel then started to egg, which ended up with a slightly positive tilt during the B1 excavation. And then the tilt meters were sensitive enough to pick up the weight of the slab during the B1 slab construction. Similarly, at the bottom right, we monitored the movement of the track base during construction, and we can see in amber, red and black the triggers. And below that, we can see the movement of the track along the length of the tunnel below the site. Again, none of the movements exceeded the trigger levels, and typically throughout the construction of the project, the movements were between half and 2/3 of predicted movements, which is in line with expectations given the relatively conservative geotechnical parameters that were used in modelling. Next slide, please. So thank you for listening this afternoon. Any questions?